And welcome to this tutorial on applying thermal imaging to roof and solar systems. Brian Burns will be joining us here in a moment. First, a few announcements. If you have any questions about today's topic or you need to contact us directly, please feel free to reach out to the Infrared Training Center. You can call us at 1-866-872-4647 or reach us via email at info@infraredtraining.com. The Infrared Training Center website is where you'll find additional free tutorials, as well as our complete global training schedule for certification classes. This includes AS&T-based levels 1, 2, and 3, as well as an ISO-based Category 1 course that is now available. Head to infraredtraining.com to learn more. While you're online, be sure to get social with the Infrared Training Center. Follow us on X, Facebook, Instagram, and LinkedIn, where you'll find helpful tips, thermal imaging best practices, and much more. And be sure to also check out Thermography Talk, now available on Apple Podcasts, where we feature these tutorials so you can learn while on the go. The Infrared Training Center also runs a number of special training offers throughout the year. So if you're looking to get certified, there's never been a better time. To learn more about these, please feel free to give us a call, send us an email, or visit the Infrared Training Center online at infraredtraining.com. So with that, let's bring in Brian Burns. Brian has worked with the Infrared Training Center since 2016 and specializes in power generation, manufacturing, and quality applications. Today he's going to talk about how to apply thermal imaging to roof and solar system inspections. Hey Brian, great to see you. How you been?
Hey, I've been doing well. How are you doing, Matt?
Doing really well. Really, thank you. Thanks for being on today. I know we wanted to talk about this topic here for a while. Before we get into it, for those that may have not met you before, just take a moment to introduce yourself, please. Where are you from and how long you've been working with the Infrared Training Center?
Sure. Yeah, my name is Brian Burns. I live in Old Orchard Beach, Maine. I've been a thermographer for over 17 years. I've sold cameras and have done inspections, many types of inspections around the United States. My passion is thermography, and I am a level 3 master thermographer, and I've been with the ITC, the Infrared Training Center, now full-time for 2.5 years, but prior to that I was a contractor for over 7 years. And my passion is to watch people develop their skills in thermal imaging, whether it be in building application, whether it be with electrical, mechanical, or even flying in choppers over transmission lines.
Nice. Well, today you're going to be talking about applying thermal imaging to roof and solar systems. I know this is part of a presentation that I think you're delivering coming up at the Pro Inspectors Convention, right, in Orlando in February?
Yes, I'm going to be there. I'm actually presenting on Monday morning, 9 o'clock on February 17th. This is an INNACHI conference, and it's the Pro Inspectors Convention. This is what they consider a commercial inspection track. And the idea behind my presentation is to really spark and get a taste into the palate of the folks that are attending, that they can actually do a lot more with their infrared cameras than just building inspections. So I'll be talking about how to apply successful imaging in these commercial environments. Some of these environments actually, the sites, when I get onto the site, it could be a heated walkways, a parking garage, water features. There's a lot of detention ponds, retention ponds, pumping stations. There may be some sewer treatment, those type of things. What about the frame? Whether we have expansion joints, we've got ephes, stucco siding, the windows, the doors. These are very important for a good environment of buildings. Making a healthy building. And then we also talk about roof moisture inspections and solar systems. What about your mechanical systems, your heating and air conditioning, your cooling towers, such structures as that. And then of course, electrical, your main switch gear, disconnects, receptacles and lights and computer rooms and servers and your battery backups. What I'm going to be talking about with you guys today is roof moisture inspections and also solar systems. Now, when we talk about roof moisture inspections, we realize there's different types of roofs. And so whether it be a ballast roof, a rubber roof, an EPDM, or a TPO type roof, it really, you've got to determine these things before you get up onto that roof to figure out what you're looking at. And then, of course, solar systems. And there's many components to a solar system. And so when we take a look at solar systems, I want to give you some hints and some really tips on how you can be successful in finding the anomalies that may cause a system to fail.
Well, that's great, Brian. So we'll get into it. Tell us about what goes into an infrared roof scan. What should someone be thinking about as a thermographer if they're doing commercial roof inspections for moisture?
Yeah, Matt, there's several things that we want to take into account when we do a roof inspection. You know, first of all, I've got to figure out what type of roof, what is the system itself? Are we talking about a ballast roof? Are we talking about river rocks on top of that roof? Are we talking about just a rubber membrane or maybe a polyvinyl membrane? So, you know, we need to take a look at really what is the reason for that roofing system, and of course is to keep the water out of the structure. And the other thing that can happen with roofing is that if there is moisture in between, say, the substrate and the actual membrane, we can get liquid diffused into small quantities or drops, which we consider vapor. And of course, vapor can cause that M word that we don't like to talk about, mold. And so, you know, we really are looking for that water intrusion and how it destroys a building. And so, you know, the real fact is, Matt, it takes time. Any type of thermal imaging, you got to remember, this is we're looking at thermal energy, we're looking at heat, and you know, just because I got a camera in my hand, if I don't understand how to use that camera, how to thermally tune it, if I haven't taken any formal training, I'm not going to be very successful in finding these anomalies that might present themselves up on top of the roof. And if I can't find them, and if I don't understand what's going on, I can't explain it to others, you know, which are the customers in which I'm doing the work for. Now, you know, when we talk about roof inspections, there's a certain time that this moisture will present itself to us. And so we take a look, and again, if the roof is heavily ballast with big rocks, then we've got to really work hard to be able to find that moisture that might present itself to the infrared camera. So what's going on in there? Well, we can see right from the slide that a dry roof at night, if we wait about an hour after the sun goes down, a day before, a nice heavy rain, so the roof now has introduced moisture between the actual membrane and the substrate. And when that roof cools down towards a nice, clear, dry night, it's going to cool quickly. Where that water is trapped, we're going to have this thermal crossover where we're going to be able to see the heat. Because water has such a high heat capacitance compared to the actual membrane, we're going to see that on the roof. We do not want a cloud cover that night that we're doing the inspection, and we really want to have a difference in temperature between the roof itself and the air temperature, usually around 18 degrees. Now, here's a couple instances where moisture is found. On the left, we see that there's a seam leak to a rubber roof, an EPDM roof, and it presents itself very, very well. And those areas that are bright, white in color, is where that water, that moisture underneath the membrane has retained its heat because of the thermal capacitance of the water. On the right, we can see also that we have a wet area, but this is a built-up area of asphalt and sheets of reinforcing fibers, kind of like fabrics like fiberglass, or it could be some kind of felt paper. And this is the characteristics, and then throw on top of that some pea rock or some river rock to ballast the roof down, and you can see that it's just not straightforward. And again, I wanted to give a plug. If you don't know how to thermally tune your camera, then you're not going to be able to find these anomalies as quick as possible. So training is very important. Now, baseline study, I've been hired many, many times by roofing companies that actually put down the roofing materials. And what they want to do is they want to prove to the customer that the roof is fine. And they also want to be able to yearly have me or another thermographer go up and do an inspection of the roof. what we want to do is make sure that the roof is not failing. Better to catch it early than too late. And so that baseline is very important to take images. And as you can see here, I'm looking down onto the roof. A lot of times what I'll do is also go on to Google Maps, and I'll just take a look in satellite view, and I can detail, if I do find a problem, I can detail that in my report. What is the manufacturer looking for or from me? He's looking to make sure that when the roof was laid down, the membrane, that there is lapping material and that the laps are not too large and not too small. And also we're looking for the end laps of where we run from the end of the roll, we get done with one roll and we're beginning the next roll. It's important to have a good 3 to 4 inches of an overlap. And thirdly, if we've got insulation going down on top of the roof, some kind of foam board, we want to make sure that those fasteners have been connected properly. If they're not, then we could have lift on the roof and the whole roof could fail, and that's not what we're looking for. Now, the roof itself, when we do find an anomaly on the left-hand side upper picture, take a broom with you or a rake and rake away the ballast. This is small P-rock that's up on top of the roof. I see that I've got an anomaly there, and so what I'm saying to myself, okay, I want to get a clear view of that, so what I want to do is sweep away some of that rock. And on the right-hand side, you can see that a spray can has been used to actually mark out where the failure is in the actual roof, the membrane on the roof. I don't recommend spray paint. I would rather see you use a chalk material, something that can be, that's not going to affect the actual membrane itself, because that will affect the warranty of the roof. So you've got to be careful of what you're using there. Secondly, because of safety, I don't want to be walking off the roof into the parking lot or off one roof to another. I always recommend that you have somebody on the roof with you. And if that's the case, that person can use the chalk or whatever marking medium you're going to use. I just use the laser pointer on my camera and I detail where to mark that, so that the repair person coming up to repair that section of the roof can core it, make sure that the substrate is not ruined underneath it or oversaturated, and then can do a nice seal, whether they weld a new piece in or they're going to be applying maybe some asphalt to the roof. What you see in the lower left-hand corner is just simply a detailed that I grabbed from a satellite view, and I can actually point out these wet areas so that the repair person, the roofing company, can find where the anomalies are. And then again, make sure you take visual pictures. And what I recommend is take these visual pictures while you still have sunlight. Go up and identify your air handlers. Identify different areas on the roof that may be potential problems. That way there, when you do find that problem, you can link it up with your visual pictures that you took that afternoon before the sun went down. Again, what we're talking about is that pre-sunset, getting up on the roof. The customers indicated to me that they have this leaking. They got wetness in the stairwell, so they want me to locate where that is. And so very crucial that I get there earlier in the day and that I get a good lay of the land, or should we say a good lay of the roof. It's pretty difficult when the sun has gone down for you to now start trying to navigate around that roof for safety reasons, and also you're just going to miss the opportunities to where there's potential problems before you even do the infrared scan. And so on the right you can actually see where that glowing water, where the circles I've drawn in there indicates, yes, there is definitely moisture trapped underneath the membrane. When we talk about ballast roofs, there's quite a bit of material up there, and you can see there's P-rock. Sometimes there's even river rock, big boulders that they'll put up there. This is not untypical. With a ballast roof, you are going to find a lot of entrapment of water. If there is a problem there, it will present itself. And you can see right here, we're near the parapet wall, just underneath it, and we've got some water flowing down underneath the asphalt and the ballast on the roof. And again, I sit there and I've never had the chance to use drones. I really wish I could have, but I'm kind of been out of the industry with teaching now. But we do have an excellent drone class that Bill Swan teaches, and he talks a lot about using the drone and finding moisture on the roof. Boy, you can do a roof inspection in a fraction amount of time, very efficiently. The only issue would be your angle of acquisition. And if you've got too low of a viewing angle, you're not going to see the moisture. The same way with a handheld camera. If you're looking out 15, 20, 30 feet out away from you, you're going to end up getting reflection of the sky off from the roof. Typically more on your PDM roofs than say on your roofs that have got asphalt on them or a ballast like P-rock. So here what we're looking at is making sure that we have a good viewing angle. Get up on top, get that drone up above and looking straight down, not at an angle like you see. And here again, we can see that we're getting some reflection. We've got solar panels up on the roof, but we are getting reflection also off the roof itself, off the membrane. And so reflections are a killer. And we spent a lot of time in our trainings at the Infrared Training Center talking about reflection and just how inspectors, thermographers get fooled by reflections, whether it be in roof inspections, whether it be in building inspections or looking at window glass, or even looking at electrical components. The reflections are sometimes take a time to understand and to be able to work past them so that you can be very successful in your thermal imaging. And again, when you find an anomaly, I don't care if it's an electrical anomaly, a mechanical anomaly, or whether it be a roofing anomaly, you need to verify it with some other piece of equipment. Here what I'm showing you is a Trimx deck scanner. It's an excellent machine. So when I think I've got a place that's presenting moisture, I will go and double check it with the deck scanner, and if I see that it's also indicating moisture, then I can pretty definitively say we have a moisture problem here. I've always been amazed when I talk to folks that are doing building inspections and they're looking for moisture in behind sheetrock, but they don't bring a moisture meter with them. You're kind of shooting in the dark. The only way you'd really be able to tell if you've really got a problem is to actually put a hole into it. Remember, this is non-destructive testing, so it's very important to have that verification tool. And again, the Trimx deck scanner is an excellent tool for that verification that there is indeed moisture trapped between the layers on top of that roof.
So, Brian, besides roof moisture inspections, you're also going to be discussing solar panel systems, right, and all their components?
That's exactly right, Matt. You know, when we talk about solar systems, a lot of you folks have seen on homes maybe next door, maybe you've got them on your house. It seems to be the up-and-coming energy efficiency that we want in our country. And so there is components that are involved with commercial solar systems and also residential. So let's talk about, first of all, in our minds we need to be saying to ourselves, what type of panel is it? Who's the manufacturer of the panel? Not all panels are the same, or do they act the same? Also, what is the sun acquisition onto the panels? You know, it's important that the panels are somewhat directed towards the sun, not down towards the deck. And so are there any obstructions that are blocking the panel? And we'll talk about some more of those obstructions, whether it be a natural obstruction or whether it be something caused by nature. When we get up onto a roof system, or whether we're on a ground system, say in a solar plant or a solar farm, we got to combine our solar panels together. Now, what you'll generally find is that we have so many positive panels and so many negative. They're sending in because it's a DC system. And where this goes into is combiner boxes. And you can see a picture here of a combiner box. And this may be the positive side of 96 panels that have been combined into this box before it heads down to the inverter. We also talk about the inverter. This is where we're taking the DC power and we're making it into usable power, or AC power. And so the inverters could be, like you see here, a large commercial inverter, or it could be converters that are actually right there just below a group of solar panels, whether it be in the home before it heads into the grid, or whether it be right in being used, say, agriculturally, hanging right down below the actual panels. We also have to keep in mind the racking. When we talk about racking, what we really need to be thinking about is how is the structure connected to the building or to the ground? And that is part of your inspection. That's a visual inspection. It's not just enough to have that camera on and be looking at the panel faces, but also be taking a look at the structure. There's different types, and so look for loose panels. And I've found a lot of loose panels on the roof, and just wiggling them. If it's loose, eventually it'll come off and can damage many other panels within the group. The other thing that, as you can see on this array, is that you need to be thinking about your acquisition angle onto the actual panel. So I'm going to discuss that in a little bit. What are we talking about with wiring and connections? Where are we looking at? Now, if you take a look at these, the connectors here, these conductors, we see that there's a insulating shield around the actual copper wire. That is a perfect place to find, if you do have a loose connection, that's where it'll present itself. It's on that shielding, not on the actual connection, which you can see down there is metal. And that metal is going to cause some issues with reflection. When we talk about the solar system and its components, we need to be talking about the actual, something like the TriStar MPPT controller. These controllers are very common when you get into large solar systems. And for example, IKEA uses their solar systems, which are up on top of the roof, the panels, over 5,000 per roof on an typical IKEA store. They use they generate power from the roof, and they actually use it in their stores. They're not sending it into the grid. And so this type of system may be on the system that you're looking at, or may not be. But if it is there, you need to get inside there to make sure that there's no loose connections. When we talk about battery backups, this usually is something that would allow say a data center or some kind of critical operation to stay operating if there was a glitch with the power company or the solar system in conjunction. This gives a little bit extra time for to be able to switch off the equipment, or to get it onto another load or another incoming line from, say, a utility or from a generator. So again, this is all part of your inspection, is to get into these components and to look at all connections within them. Now, what are the conditions that the International Electrical Technical Commission, which we know as the IEC, what is it that we're looking for to give us the ideal conditions, monitoring conditions, when we do the inspection? And so what we really are looking for is better than 600 watts per meter square. This is the actual amount of energy that is coming from the sun, radiant energy to the actual panel. Anything less than that, the panels are not loaded enough. So early in the morning, probably not loaded enough, or after the sun, just before sunset, not loaded enough. So what we need to use is a pyrheliometer. It's not a lux monitor, which you would use for, say, LED lights. This is really for the radiant energy of the actual sun that's hitting the panel. We want to have at least a good coverage of sun in the cloud. So if you've got 2/8 sky coverage, you're doing well. Anything more than that, it's going to block the sun's energy from hitting the panel. Cumulus clouds are fine. If we start to get into overcast conditions, you're probably not going to be very efficient at looking at the panel faces to see if there's any anomalies or any of the other components within the system. As far as wind, something under 17 miles an hour, pretty good. So you want to have an anemometer with you so you can check the wind speed. And also you want to take a look at less than 10% soilage or dirt that's on the face of the panel. That includes things like bugs that have been splattered against the panel or have died and dropped to the panel, and also bird droppings. And also, when we talk about the load on the system, you can check this very easily. You're either yourself, or if you're not an electrician, have the electrician with you. Check to see exactly what the load is, and we're looking at least a 30% load to make sure that we're able to find those anomalies. So many potential inspection targets that we've got to also keep in mind is cells that are degraded. Whether or not we've got broken bypass diodes within the system, delaminations and cracks in the glass, moisture intrusion, and you'll be able to pick that up very easily. And I'd mentioned already about bird droppings and shadowing. And the glass itself is pretty robust, but sometimes that can even be damaged by the acid or something getting onto it, say fuel. If you've got tractors nearby, maybe diesel fuel being spewed out and just with droplets onto the glass. Now, it's also necessary to stay at 90 degrees to the actual face of the panel. You can go as low as 60, but anything below that, you're going to start to introduce a lot of reflection, whether it be from the trees, the sky, the sun itself. And this angle is relative to the panels, not to the horizontal or the ground. So we want to make sure we have the right viewing angle. Now, typical anomalies that you'll find in is your heated cells. I've noticed that sometimes in the morning when the sun's coming up, that your panels are waking up. You've got to make sure you're up and looking at these panels while you have full exposure. If not, you're going to see some anomalous patterns that are really typical of solar panels. But here we see a heated cell, which indicates that we've got one cell, maybe two cells that are starting to fail. And so, if that's starting to happen, it's going to continue to cascade down through the panel itself. Short-circuited modules that are behind the panel, you can see also from the face of the panel. And so we're looking at here a substrating or a loop. So what's happened, that open loop is causing eventually a short circuit within the panel, or modules in an open loop. So, it could be just one panel, or it could end up being the whole string of panels. And here we can see, on the rooftop, we've got, three cells that are definitely have got an issue. And so it shows up as a thermal anomaly or as heat. Instead of transferring that energy from the sun to electricity, it's just now just creating heat on the surface of the panel. And the same thing we see here is a saturated cell that they're not converting sunlight to energy like they should be. They're actually just creating heat. And it's interesting because a lot of folks, they don't realize you need to also check the panels from underneath, if you are able to. Some cells are very close to the roof, like in the previous slide, very, very difficult to do so. But on other panels, if you're out in a solar farm or a solar plant, much easier to get behind those panels. So make sure you get behind them, take a look at what's going on. I talked about debris, things that can get onto the surface. The number one killer of these solar panels as far as producing energy is dirt. And these panels should be cleaned at least twice a year, if not more. And I'm always amazed when I talk to folks, or even in my neighborhood, they've got panels on the roof, and I say to them, I've never seen you clean your panels before. And they go, no, I haven't cleaned them. Why? And I'm like, well, you're supposed to. You've got a lot of grime up there. It's cutting down on the efficiency of the panel. The other thing that really can destroy a panel is, strikes. So you're figuring, well, what do you mean? Are kids throwing rocks onto the panels? Well, no. You've got seagulls, for example. I remember working down in New Haven. I was on top of a roof of a large commercial building, and there were seagulls everywhere. And what they were doing is dropping either a rock, they were trying to drop it onto a shell, say they got out of a lobster shell or clam shells out of a dumpster, and now they're trying to break them open, and they're dropping rocks onto them. So that, and also feces. The panels were just covered with bird feces, and so again, we've got to look for those extrusions, because it does decrease the amount of output from the panel. So, briefly, and again, I would recommend if you've got a drone, that you would take our SUAS drone class. It is excellent, and you would get a better appreciation. Now, we're not going to teach you to fly the drones. That's something you have to take care of, that Part 107 on your own. But boy, you will get a good lesson. You'll understand more and more about viewing angle and about reflectivity and other issues that you're going to run into when you do thermal imaging underneath or on a drone. So, it's much easier, much more accurate to use the drone. You can, do these huge solar plants or solar fields or solar farms much quicker with a drone than you can walking it, walking the fields. And again, in the damage modules, very easy to pick up not only visually but also thermally. So use your detectors, not just your thermal detector, but these detectors here, your eyes. And so really, in conclusion, when we talk about solar panels, these are some of the components that you're going to be looking for and some of the anomalies, whether it be in the combiner boxes, whether it be in the inverters, whether it be on the surface or the face of the solar panels. There's many opportunities for you as a thermographer to be able to use your skills and really to provide a service to your customer that maybe they hadn't been thinking about.
Well, that's great. Thank you very much, Brian. Really enjoyed that presentation. Again, this is a preview of your upcoming presentation at the Pro Inspectors Convention. This is in Orlando, Florida, February 16th to the 18th. When are you headed down? Do you know what time you're slotted for?
Yeah. I'm going to be speaking on Monday, February 17th at 9 o'clock. It's a 2-hour session. I'm really looking forward to being with you folks. I just get really excited about thermal imaging. So this is what they call the commercial inspection track. And again, as I talked about earlier, these different areas that you have, whether it be, you go outside, you're doing say a parking garage and they've got in-floor radiant heat. You'll have the ability, after walking away and after I present with you, to be thinking about, wow, what do I need to have for conditions to be able to see those heat tubes in the floor? So, we're going to be talking about overall all the opportunities that you have to be able to do thermal imaging of commercial building inspections. And I look forward to seeing you there. Please stop up and say hi, and we're going to have a great time. I guarantee it.
Oh, that sounds great. Well, thank you again for your time today, Brian. Look forward to working with you again soon.
All right, Matt, and it was a wonderful day, and I look forward to doing another segment with you soon.
Remember, if you have any questions on today's topic, please feel free to reach out to the Infrared Training Center directly. Call us at 1-866-872-4647 or reach us via email at info@infraredtraining.com. Our website is where you'll also find other free tutorials on a variety of topics and our complete training schedule. Plus, we also run a number of special training offers throughout the year. To learn more, give us a call or visit the Infrared Training Center online at infraredtraining.com. Thanks again for watching, and we'll see you online again soon.